Hello, class. We're going to get started with a review for test number 4. And so this is a review that's in your module related to test number 4 in your Canvas course for Math 410. And it's a version of the test that I created, from the Hawks Learning platform. And your test would be similar to that. And so I also have a template here that I also printed that if you have a printer, you print that. And most of them is mostly problems numbered, spaced out, horizontal lines. But there's a few, because sometimes I add hints and things to them. So the hints come in like on problem 15. Determine if the polynomial is a monomial, binomial, trinomial. So you're classifying that, and then determine the degree and the leading coefficient of the polynomial. There's some substitutions for function using function notation. But then other than that, there's a lot of empty spaces with horizontal lines. Then at 20, there's an option. You can use FOIL or the distributive property or the box method. So you have a choice when you're going to be multiplying two binomials. And then you're going to have a problem where you're multiplying a binomial, two terms, times a trinomial, which has 3 terms. So you can use the box method or you can use the distributive property. Then these last two are these related to section 12.7, the special products. And so you are required to show your work using these formulas that are provided on this template for special products. So this looks like it's the difference of 2 squares. That's why we call it dots, difference of 2 squares. And this formula looks like it's the perfect square trinomials formula, also called the square binomials formula. And so for these, you want to identify your first terms and your second terms, and then you want to plug them into these formulas. And so we usually, when we identify the terms, we usually just take the absolute values and make these positive terms. We don't worry about the sign because the signs see already built in. This one will always be a negative. And on this formula, this one, they're all positives. And so, so that's the little hints that are in that. So for this one, if you don't print the document, you can show your work on your own paper, number your problems, but you might want to write down some of those problems or those formulas that you saw on your paper before your test starts, okay? Then this is a supplementary sheet in that same location where your test review is located and where your template's located and your module related to test number 4 over chapter 12. So you might want to, if you do have a printer, you might want to print this out and look at it and read it because it is helpful. This was created back when we had face-to-face classes and students were allowed a handout that was created by the instructor, and they passed that out during the test. They could use that during the test. So it does have information like a summary of each section, and it could be helpful for someone taking a test. So you can look at that and decide if you want to print that and use that. But it should be information that's similar to what's on your first page of each lesson as well, because you also are allowed the first page of each lesson that has the rules. Okay, so we're going to get started then, okay? And so let's see, I have this review has an answer key at the back, so I will make sure I use that to make sure I'm not making a mistake on the problems, double check. And we'll start with the first one. Oh, and let me just see. This review has to 23. Okay. And your actual test looks like your actual test. Okay, 23. Okay. I just wanted to double check. Okay, so the first one says, simplify the expression using the properties of exponents. Expand any numerical portion of your answer and only include positive exponents. Okay, so you have this quantity 6 to 7 raised to 0 power. And so this is saying that any number or variable raised to 0 power, do you remember what that equals? And that equals 1. Okay, equals 1. On the calculator, you wouldn't be able to show it because there's no way of us typing in the x into the, we can type the parentheses in the 6, but we won't be able to type this x in. So that's why you do need to know your definitions, that any number or variable, any number except 0, right? So any number, any real number, not the complex. So any real number except 0 and any variable raised to the 0 power equals 1. So the reason why they say except 0 is because there is a special case that 0 to the 0, that is a special case that's considered undefined. Okay. All right. And probably what you should do is you probably should like pause the video and like try to work number 2 on your own. And remember, time yourself. You want to spend about 4 minutes or less working a problem. It's usually the average time you want to spend on a problem. So you probably should pause the video and then work number 2 and then turn the video recording back on so that you can check your work against what your teacher does. Okay. So 2 says, simplify the expression using the properties of exponents. Expand any numerical portion of your answer and only include positive exponents. Okay. So here you're multiplying 3 different terms. They have the same base of x and they're raised to different exponents. So this is where you should keep the base and add the exponents here. Okay. That's one of your product rules. So when you show your work, you want to keep your x and show that you're adding -6 plus 10 plus -7. So you should show that for your work and then calculate that. So of course you can use your calculator as a guide to help you with that. If I do it by hand here, -6 and 10, that's a +4. So this equals 4 plus -7 and 4 plus -7, that would equal a -3. Okay, so you're adding 2 numbers with different signs. So you really subtract 7 minus 4 is 3. And then remember the 7 has the LAV, right? The largest absolute value. And so you put the little negative to show that you're going to keep negative on that 3. So then the answer is x to the, oh, just a second. So then we have this as x to the -3. But the reason why I said just a second is because remember the instructions said that they only want you to include the positive exponents in x to -cube. So this is a negative exponent, so they wouldn't want us to leave it like that. They would want us to do some more work on it. Now, if you're doing scientific notation, a times 10 to the n, a times 10 to the n, where n can be an integer, then that would be okay. But this is not scientific notation, and that's why you cannot leave this with a negative exponent. So you have to basically relocate it, relocate the base, and you also have to remove that annoying little negative, remove the negative on the exponent. Okay, so right now there is like an imaginary 1 underneath that x to the negative that we never bother writing. It's understood. So when we say relocate, you need to relocate that x to the bottom. So it should end up being like this, x to the bottom. And then you need to remove that little negative on that little negative exponent on that 3, that power 3. And so that's why we would say that this is equal to 1 over x cubed. Okay. Okay, if you look at number 3. So again, remember you want to stop the video and work the problem yourself, and then turn the video back on. So simplify the expression using the properties of exponents. Expand any numerical portion of your answer and only include positive exponents. So this is more practice on number 2, it's more practice. So on your paper, you want to show it's the product rule. When multiplying like bases, you keep the base and you want to add the exponents. Okay, so we're using this called product, which was the same rule we used over here as well. Product rule. Okay, so if you add 8 plus negative 6, that will give you 2, right? 8 plus negative 6 is 2. And so on the computer, you're going to type x to the second power, x squared. On the computer, you type that in. Okay. Okay. Then number 4. So simplify the expression using the properties of exponents. Expand any numerical portion of your answer and only include positive exponents. So this negative 6 to 0, that's equal to 1. And that you can show, that's the definition, but if you don't want to do your definition, you can show that by putting parentheses, negative 6, close parentheses, and then you raise it. So here's my caret key. And if you don't have the caret key, if you don't have this kind of a calculator, some of you might have this key. Some of you might have this key. These are all keys that activate the exponent. Okay. So usually the calculators don't have all of them. Usually it'll just have one of them. And it just depends on the age of your calculator. Because it first, I don't know which one was older. I think, maybe it started with this and then it changed to this, and now we have this. Okay, so it's evolved, but that represents raising a power, raising a base to a power. So this does give you 1. If you raise it to the 0 power, enter, that does give you 1 if you don't know the definition. So just cross that through on your paper, put a 1, and now you're figuring this. And this means negative 6 times negative 6, okay? And you can also put this in the computer, parentheses, negative 6, close parentheses. You can say raise to the second power, okay, which is 36. Negative 6 times negative 6, that will give 36, okay? Also, there's a square, see? So you can also do parentheses, negative 6, close parentheses, and then if you just hit this because it's squared, that one, then you don't need to have activate any of these, then you just press that, let's say squared, and it gives you 36, okay? And then on the bottom, simplify this expression using the properties of exponents. Expand any numerical portion of your answer and only include positive exponents. Okay, so remember, it's best for you to stop the video and work it and then turn it back on. So what's going to happen here is this is using the quotient rule. So this is called the quotient. Earlier, we were doing the product rule. This is the quotient rule. What you're supposed to do with the coefficients is you're supposed to try, if you have any coefficients, and we do, coefficients should be reduced, okay, to lowest terms, because you have fractions. So you want to reduce them, or we say simplify. That's what you do to fractions. You simplify or you reduce. Okay. And so it turns out that this negative 10 divided by 2, it turns out that one can be simplified. And you can see here on the calculator, negative 10 divided by 2. You can see that gives you 5. Okay. So it's not reduced, but it is simplified. So that is part of your answer for number 5. Okay, but now you have to handle the quotient rule for the like bases of x, and that says to subtract. So you want to subtract, and the idea is top minus bottom, top exponent minus bottom order. So this is negative 10 divided by 2, that gave us 5. You have to keep your base, and then you're doing 5 minus 3, because it's top minus bottom. And 5 minus 3 is 2. And so this would be 5 and then x to the second power. Okay, next page. Simplify the expression using the properties of exponents. Expand any numerical portion of your answer and only include positive. So this looks like more practice on the quotient rule. And so you want to, keep your base and subtract your exponents. So your base is x, and you're going to subtract your exponents. And remember, when you subtract, it has to be, remember we said top, take away bottom. Okay, so that means we have a negative 1, take away 6. So negative 1, take away 6. Okay, and that's keep, change, take the opposite. So negative 1 plus negative 6. So keep, change, take the opposite. Okay, and then negative 1 plus negative 6 is negative 7. So this is going to be equals to x to the negative 7. And remember that you cannot leave answers with negative exponents. For this comment, they want you to include positive. So you do, and it's not a scientific notation problem. So you do have to tweak that and use the negative exponent rule. And, this has an imaginary 1, at the bottom. We just don't bother writing that. But you are going to have to relocate that base, and you are going to have to remove that annoying little negative. Remove that negative on that exponent. Okay, so then the x of 7 is going to go to the bottom. And when you put the 7, you're going to take off that negative off of it. And then you can't leave the top part vacant like that. And there's nothing else to put there. So you do have to put a 1 for that. Okay. Okay, number 7, simplify the expression using the properties of exponents. Expand any numerical portion of your answer and only include positive exponents, okay? And so you want to multiply. This is, you're using like a power rule. This is using one of the power rules. And so basically you are going to keep the base and you're going to multiply your exponents. And it's inside times outside. So inside times outside, 4 times 3. So on your work, you can do the arrows. And in class, I said you can do the arrows. And probably it'd be better just to do instead. Or you can actually, you know, do 4 times 3. Or you can do parentheses, you know, like that, 4 times 3, something like that. Okay. And that on the computer, that would give you, you're going to input worth the 12 power. And why the 12 power? Excuse me, why the 12 power? And for number 8, simplify the expression using the properties of exponents. Expand any numerical portion of your answer and only include positive exponents. Okay. So this has a fraction and it has a negative power. So the best thing to do here is to relocate these and then remove this negative on that. Okay. So you're advised to relocate. And then you're advised to remove the negative on, and we're talking about on the outer exponent. Okay, so you're going to put on top a to the first power, imaginary, b cubed, then the bottom 2 to the first power. So what's in the numerator goes in the denominator, and what's in the denominator goes in the numerator. And then I'm just putting imaginary ones. These do have imaginary ones. The book just doesn't bother writing them, but this would be helpful for us to do that. And then remember, you got to take off this negative, that negative, and third power. And then you're going to multiply the inside exponents with the outside exponents. Then you've got to do that 3 times. So you see, one here, another one here, and then another one there. So you're gonna have to multiply your exponents, and it's the inside exponent times the outside exponent. Okay, so you would have A, if I show this, 1 times 3, and then B, 3 times 3, and then the bottom for 2, 1 times 3. Okay, so you have A to the third, because 1 times 3 is 3, and then you have B to the 9, because 3 times 3 is 1, and then you have 2 to the third. Okay, now the thing is that with 2 to the third, I'm not going to put 2/3 here, because so you have A cubed, B 9, but then you have 2 cubed. So I can simplify 2 cubed. 2 cubed is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. And if I show you that on my calculator here, two raised to third power. See, that's 8. 8. All right. So this part, if you don't want to show this part on your test, that would be fine, but then do your arrows, at least do your arrows. But then after you do your arrows, you do need this intermediate step here. Okay, and then the computer, you put final result. Okay, number 9, simplify the expression using the properties of exponents, expand any numerical portion of your answer, and only include positive exponents. So you have this 2 and then y to the -1 inside parentheses, and then raised to the -6 power. Okay, so with this one, I would advise you just to insert like your imaginary 1 on that base of 2, and then you can just go apply your arrows here and just multiply the inside exponent with the outside exponent. Okay, so this number 9 is a little bit easier and a little different than number 8. So if you're wondering, like with 8, because 8 had an outer negative exponent, and so does 9 an outer negative exponent. But you're wondering why your teacher relocated the quantity inside parentheses on 8, it was because it had a fraction. It had a fraction, and that's why we had to relocate these and then remove the negative on this outer negative bit. But see here inside parentheses, you don't have parentheses, you don't have fractions. You don't have fractions. So that's why it's a little bit easier. You just have to multiply. You're just multiplying your exponents, and it's the inside exponent with the outside exponent. So for 2, you have 1 times -6, and for y, you have -1 times -6. And so 1 times -6 is -6, and a -1 times -6 is +6. And then this 2 to -6 has to be relocated. This you want to relocate to the bottom, relocate, and you want to remove that negative on that exponent. Okay, so then when we rewrite it, I'm going to put this fraction bar, and I'm going to put the 2, 6 on the bottom. So I'm relocating it, this to the bottom, the base of 2 to the bottom, and I'm removing that little negative on that 6. And then the y is fine where it's at. The y will stay, in the top here, stay on the top. It's just this that gets relocated. And then you can use your calculator on 2 to the 6. So this is going to be y to the 6. And then you can use your calculator to see what 2 raised to 6 power. 2 times 2 times 2, right, over and over, 6 times 2 times. So it's going to give you 64. Okay. Okay. So on number 10, simplify the expression using the properties of exponents, expand any numerical portion of your answer, and only include positive exponents. Okay. So with 10, I'm going to put a little imaginary 1 on 2, but then I can draw my arrows and start multiplying all my inside exponents with my outside exponents. Okay. So the reason 10 is a little bit different from number 8 over here. See, because number 10 inside has a fraction, just like number 8 inside has a fraction. However, if you look at the outer exponent, there's no negative on it. So on number 8, you had a negative exponent on the outside. That's why we had to relocate these. Okay, but I'm not going to have to relocate the quantity on number 10. These will stay put because if I look at the outer exponent, there is no negative on it. It's just 3. So these will stay put, and but we're going to have to multiply, right? On the 2, you're doing 1 times 3. On the X, you're doing 3 times 3. On the Y, you're doing -1 times 3. Okay. And then on the bottom, you're doing Y, 3 times 3. Okay. So then we have for 2, 1 times 3 is 3. For X, 3 times 3 is 9. And for Y, -1 times 3 is -3. Okay. And then on the bottom, 3 times 3 for Y is 9. Okay. So you can either do the arrows and go from here, the arrows to this, or you can take this intermediate step here and show me 1 times 3, 3 times 3, -1 times 3, the bottom, 3 times 3, you can do that, and then multiply that out. So either the arrows or this, fine. But then when you look at what you have, you can use your calculator on 2 cubed. So it's 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. 2 times 2, 2 times 2 times 2 is 8. And the calculator shows that. So you have, this is now 8. And the x to the 9 is fine where it's at. Okay. So, but what's going on here, okay, what you can do here is, it would be okay for you to relocate this. This could be relocated down here at the bottom. So this now goes to the bottom. And when it goes to the bottom, you remove that little negative. You remove that negative, relocate it. So you could do that. Okay. And then now you use the product rule on y9 and y cubed. You use what they call product rule. So you're adding those exponents. So then you would have, we said 2 cubed was 8, x to the 9, and then on the y you have 9 plus 3. On the y we have 9 plus 3, which is 12. Okay, so you would have 8 x to the 9 on top, but then you have 12 on the bottom. Okay, and so you're showing your work, you know, you're showing how you got 8 and how you got 12, 9 plus 3, and you're showing that this moved to the bottom. Okay, so that's one way you can do that. The other thing you can do, if you don't like showing this part moved to the bottom and adding it, the other thing you can do is you could use the quotient rule on this part. You top minus bottom, you could do that. If you do that on this, y to the negative cubed over y to the 9. If you do that y to the negative cube or y9, this would be y, and you do -3 minus 9. -3 minus 9. And that gives you -3 plus -9, and that gives you a -12. Okay. And then y to -12 tells you that it's not in the right location. It needs to be moved to the bottom. So you see, we did move it to the bottom, and when you move it to the bottom, you take off the negative. See. So also see how 9 is bigger than -3. 9 is bigger, so that tells you that your result has to be on the bottom, because 9 is bigger than -3, and it was. We did put it on the bottom. So there's a couple ways of handling that. So you can either do this method here, or you can show that. They're both, one is just as good as the other, just depends what your preference is, and you're still showing. Okay, so now let's go to 11. Simplify the following expression using properties of exponents. The final form of the expression variable should contain only positive exponents. Assume that all variables represent non-zero numbers. Okay. So I see the a to the 0 right away, and what you can do is put a line through it and say that gives you 1. The other thing I see here is you have this fraction 28 over 42. So we definitely can reduce that. And you're safe with 2. You're safe with 2. Maybe a 4 or something else will work, but you are safe with 2 because those are even numbers. If I just start off with 2, 28 divided by 2, half of that is 14. And then 42 divided by 2 is 21. And then looks like that can be reduced again by a 7. 7 goes into 14 twice. 7 goes into 21 3. So that can be reduced. So it could have been reduced by 14. If I did 2 times 7, that's 14. It could have been reduced by 14. So 28 divided by 14 is 2, and 42 divided by 14 is 3. So it could have been reduced by 14, but we're playing it safe. We didn't see that right off the bat, right? We tried 2 because they're even, and we tried 7. So that's part of the answer, 2/3 part of the answer. But then, so let's see, I guess we could put it here. So that's 2/3 part of the answer. And then the a to the 0 was 1 by definition. That's by definition. But the a to the 5th, so we know the a to the 5th will have to stay down here. Okay, because the a to the 0 is 1, and it stays, a to the 5th is down here. And then these, what you can do if you like the flipping, you can say this goes on top, right? So that would be to the 4, whereas this goes on the bottom. And remember, when you do that, you've got to take off the negative. So the -4, you have to push the 4 on top, and the -2 push that on the bottom. But then now you're going to have to subtract. So when you subtract these, it's on the B, it's top minus bottom. So it's 4 take away 2, which is just a 2, which is a B squared. So that means B squared would go up here on top, not on the bottom. And it goes on top because see how 4 is bigger than 2, so it goes on top. Okay. Now, if you didn't want to do that and you wanted to just do the quotient rule, you go back to this. Remember, you had b to the -2 over b to the -4. Remember how you have that? B to the -2 over b to the -4. If you wanted to just do the quotient rule, you have b, it's top exponent minus bottom. So then you do have a double negative. -2 take away -4. So you do have a double negative, which is -2 plus 4, which is 2. So then it's just b squared. And that's what we got, b squared. Just on top. Okay. And then what happens with the c to the -6, I can put an arrow on that, c to the -6, and remove the negative, and it goes on top. And so c to the 6 goes on top. And okay. Number 12 says, find the indicated sum. Okay. So this is a trinomial, has 3 terms. This is also a trinomial, 3 terms. This is also a trinomial. Okay. So I like to stack them. And if I start with the highest power of the cubes, I have a 6x cubed. And then this does not have any x squares. I can do this if I wanted to. and then plus 2 to the x to the first power, and then a minus 8. Okay. Then I go back to the second trinomial and I line them up. 4x squared would go under here, under the 0x squared. Minus 7x, so that would go here under the 2. And then plus 4. And then if I line these up, 8x cubed. Oh, what I can also do is do this. I can also, there's no x cubed, so I can put a 0 there also for that, for this 0x cubed. But then now I have 8x cubed minus 2x squared. And then plus 0x, and then plus 2. So you could, what I'm saying is you could do fill in fillers. If you want to fill in fillers, these are fillers, you can do that. But it's descending order. It's x cubed, x squared, x to the first power, constants last. As a rule of thumb, constants go last. So cube, squared, first power, constants last. And then if I start adding them, you know, so you're adding these, so you have an 8 and 6 positive, 8, 9, 2, that's 14x cubed. And then 4 plus a negative 2, so 4 plus a negative 2, that's just 2. 2 plus a negative 7, 2 plus a negative 7, that would be a negative 2 plus a negative 7, a negative 5. And then maybe that's where you get calculator help. 2 plus negative 7. 2 minus 7 gets a calculator help. You really want to learn your rules. Check as a tool check. And then here, 4 and 2 is 6, right? So 4 and 2 is 6, and 6 plus a negative 8, that would give us the negative 2. Negative 2. So 4 and 2 is 6, negative 8, and plus 6 is a negative 2. So you want to subtract, and then 8 minus 6 is 2, and then you keep the sign of the bigger, larger absolute value. That one has the elevated. Okay. But you have 4x cubed plus 2x squared minus 5x minus 2. Okay. And less is more. If you put this in the computer, it will complain and it won't get correct. If you do something like this, even though these are saying the same thing, less is more. So this has a bit more symbols, less is more, saying the same thing, but these are negative x's and negative two terms there. Okay, so this is your answer. Okay. And then 13, it says write 1 79/100 times 10 to the raised to negative 8 in a decimal form. Okay, so this is a small number because this is a small number. You're like wondering, how does she know that? It's because you have a negative exponent. So that's a small number. So it's like, think of like all these zeros. Let's see what's going to be this up on the calculator. 10 raised to the negative 8. So you see all these zeros. There should be 7. 1, 2, 3, 4, 5, 6, 7. 7 zeros, and then that counts as one of the moves. So that's a very small number. 1 with a whole bunch of zeros, very small. 7 zeros. 7 zeros. This is formal, but doesn't count as one of the zeros for these two. So when you multiply a small number times this, it's going to make it small as well. So the way to make this small is you're going to move your decimal And you're gonna move it to the left, because that would make that small. And you're gonna move it to the left eight times. And you start from here where you this one, and you start moving. Okay. So this doesn't count as formal, but you'll have you need to move 8 times. This count as one move. So you have 7 zeros. 1, 2, 3, 4, 5, 6. 1, 2, 3, 5, 6, and then that's 7. And then this counts as the 8th move. Counts as, and then you have the 7. Then I think I might better check my calculator. 1.7. Sometimes it goes off, depending. It can only hold so many digits sometimes, so it just depends. But this one, yeah. See, this one it rounded it because it didn't have it. It can only store so many digits, and this one has 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros, and then it has the 1 like we have here. But then it rounded this off to 8, 7, 9. It rounded off to 8, and so we're the calculator does that because it's limited on the storage of how many numbers you can put. But we shouldn't do that. We write everything down, and an answer key would record this as the answer, not that. Okay, so this one they rounded because this was the neighbor was 5 or more, so they added 1 to that. That's how they got that. You should do that. Directions don't say to round. And then, so we move the decimals to the left 8 times. And you move to the left as opposed to the right because this is small, decimal small. Okay, makes it small. Whereas on 14, this is hundreds, thousands, million. This looks like 8,590,000. And they want you to write that in scientific notation, which means A times 10 to the n format. And your A has to be a number that can include 1, but it gets pretty close to 10. It could be 9.9, 9.8, but it doesn't actually equal 10. So you saw earlier in class, in the past, we had number lines, like here's 1, 10. So that bracket at 1. Everything. Okay. So you want to, the A has to be a number between 1 and 10, and 10 to the n is an integer. The n is an integer, so it can be anything like -2, 0, 1, 2. It's an integer. These are set notations. And so here, if your n ends up being negative, that would be okay. This is where you could have a negative exponent because it's scientific notation. A times 10 to the n, that's the definition. But let's see, we were to move this decimal. If you don't see it, it's back here, and we were to move it between the 8 and the 5, 8.5, 9, 0, 0, 0, 0. So you move the decimal over here between the 8 and the 5, so that 8.5 would be about maybe right here, maybe. It's an estimate, 8.5. But you do need that 9. So I guess I could put 8.59 there. And how many times did you, because anywhere else is too small or too big. If I put it in front of the 5, in front of the 8, if I put it in front of the 8, it's just too small. Because that's like 86 cents. And if I move it behind the 9, oh my goodness, that's too big, 859. That's just way too large. I mean, even 85.9 even that's too large. There's only one correct place to put it, and it would be between the 8 and 5. And then how many moves was that? 1, 2, 3, 4, 5, 6. So now you're thinking, do we go with times 10 to the 6? Or do we go with times 10 to the negative 6? Because we moved 6 times. 1, 2, 3, 4, 5, 6. And so remember, if you go with the positive 6, it's going to make your number big. And so you're like, do I want something big? Yeah, if I look at this is hundreds, thousands, millions. Because if I use a negative, then that's going to give me something small, decimal small. And see, that's not what you need. You don't need decimal small. So we should say that this is 8.59 times 10 6 power. And then you can drop those zeros. All these zeros, you would be able to drop them because they don't have any face value. So yeah, that would be okay. 8.59 times 10 to the 6. Okay, and then you could check your result on the calculator. You're a little iffy. 8.59 times 10 raised to the 6 power. 8.59 times 10 to the 6 power, and see what that gives us back this. And then if you were unsure with the other one, times 10 raised to the negative 6 power. See how that gives you a really small number? See, decimal small. So it's helpful for you to see that. You can check that. Consider this expression, negative 3 minus 9x cubed plus 6x to the 6. Step 1, the given expression is a polynomial. Determine the polynomial. Is it specifically classified as a monomial, a binomial, or trinomial? This has 3 terms. This is 1. The plus and the minus signs help separate the terms. So this actually has 3 terms. 1, 2, 3. The plus and minus signs help you separate the terms. It's three of them. And that's a trinomial. A trinomial. Okay. And the degree. Okay, so the degree would be, you need to look at the degree of each term. So this is a constant. The degree of a constant, this is a constant. The degree of a constant is 0. This negative 9x cubed, the degree is 3. This 6x to the 6, the degree is 6. So the degree of a constant is 0. This degree of this term is 3. You look at the exponent on x. This degree is 6. You look at the exponent on x. That's what you look at. You look at the exponents on the variable. So you look at the exponents on the variable. And that's why if you have a constant, that's why it's 0, because you don't even have a variable, okay? And so the leading degree, like the degree is the one that has is the largest exponent. And so the largest exponent between these two would be the 6. So the degree is 6 of the entire problem because it's the largest exponent. And then the leading coefficient is the number, coefficient is the number in front of the variable. So if we're talking about the largest exponent here being 6, then the leading coefficient, this is the leader of the pack, it is 6. Number in front of the variable. So it's a number in front of the variable with you know, the largest exponent. And if we look at 16, consider this function. This is called function notation. So this is red. This is red f of x. Red f of x. This is not multiplication. It does not mean f times x. That's not true. It's not what that means. It's just function notation. It's actually a fancy way for saying y. X, y. So x f of x. It's actually a fancy way for saying y. Y is function notation. They'll talk about that more in college algebra. But just so you know, that's a fancy way of writing y using function notation so things can be graphed. And so for this problem, what you're going to do is a substitution problem. See, find the value of f of 5. See, so you're gonna just sub 5 for x. So in other words, you're gonna let x equal 5. So you have to start substituting. You have to go back and say, okay, f of 5. Right here we have an x. Everywhere you have an x, you're going to sub 5 for x. So you're going to sub 5 here and here. 8 times 5 plus 6. So 8 times 5 is 40 plus 6. So that's just 46. So f of 5 is 46. So it's a substitution problem. And so is step 2. Step 2 is also a substitution problem, except this is a binomial. You're not, whereas 5 is a monomial, like one term monomial. This is a binomial too, but it's still a substitution problem, except you're going to let x equal that binomial a minus 2, and you're substituting that. So you do have to set up f of a minus 2, and you see how they have it here, so you have that there. But now everywhere you have an x, so you go back, everywhere you have an x, you're going to substitute a minus 2. So we already did that here. And now we're going to do this a times a minus 2 plus 6. So now this is distributive property. That's a distributor. Okay, but you see that you have to go back to the original, the parent, like they call it the parent function. You go back to the parent function, and everywhere you have an x, which is here and here, you're going to plug in a minus 2, and this is 8 times a is 8. 8 times negative 2 is negative 16 plus 6. Okay. And then negative 16 plus 6, that gives you a negative 10. So it's 8a plus a negative 10. Negative 16 and 6 is a negative 10. Okay, this has the bigger sign, and when you subtract, you're subtracting 16 minus 6, which is 10. And less is more. If you type this in a computer, it'll probably complain. It just wants 8a minus 10, because less is more. Even though these are saying the same thing. The computer likes less, one less little mark. Okay. Okay, 17. Perform the indicated operation by removing parentheses and combining like terms. Okay, so this is subtraction. See that subtraction? This is not a big multiplication problem. No, this is subtraction. See that? And that there's an imaginary 1 right here. There's an imaginary 1 right here. And what happens when you distribute a negative, that negative 1? basically it changes all your signs. So it's -1 times 8 is a -8x squared. -1 times -4 is a positive 4x. -1 times 4 is negative. So you do have to do that first before you do anything, is you have to recognize it's imaginary -1. And that changes all of these signs, because -1 times anything changes the sign to its opposite. It changes the sign to its opposite. So this is now -8x squared. This is now positive 4x. This is now -4. So you're changing, you have to change signs on the second poly. It's a trinomial, but I'm just calling it a poly. And it's because BC means because of the imaginary -1. But then now you can start, I like to stack them. So now you have a -7x squared plus a -8x squared. So you can write it horizontally or stacked. And 8 and 7, I believe it's 15 negative. And you keep the base, So you keep the base, x squared, keep it. And you combine the coefficients. And then you have the 4x plus 1x. This 4x plus this 1x, that's 5x. And then you have -7 and this -4. -7, 7, 8, 9, 10. So that's -11. So you basically have a -15x squared plus a 5x minus. So you're showing your work and then type that in the computer. Multiply the monomials using the product rule of exponents. Okay, so this is kind of going a little bit back to 12.1, where you're going to use the power rule on the bases, and you have coefficients, so you're going to also have to multiply your coefficients. And on the power rule, that means you're going to add the exponents. So it's a little bit out of order. That really could go into a 12.1. That could have been in the very first part of the test. That really falls into a 12.1, but they kind of have it as a review here, and that's fine. So 7 times -3 is a -21. And then what's happening here, let me do this. 7 times -3. On the x's, you're going to have to add the exponents. So you're adding a 2 plus a 4. And then on the y's, you're also adding the exponents. So these have imaginary ones. So you have this one. Okay. So 7 times -3, you're multiplying the coefficients, it's -21. And on the x's, you have 2 plus 4, which is 6. And on the y's, you have 1 plus 1, which is 2. Okay. And then on number 19, multiply and simplify if necessary. Okay. So this is like kind of like this distributed property. This is distributed property here. So you want to multiply, the 6 times the 9. Okay. See, that's a 54. So that's a 54. And then you're gonna keep the base of x, and you're gonna add 2 plus 2. This 2 plus this 2, which is x to the 4. Okay. Then you're gonna do 6 times -7, which is -42. So I can double check that if you want. And then on the x's, you're doing this 2 plus this 3. 2 plus 3 is to the 5th power. So this is -42 x to the 5th power. Okay. Okay, then you have one more distributive property. So now you're doing 6 times -4, which is -24. And then it is with respect to x squared. We have -24 x squared. Okay. So this is, think of this as distributive property, okay? So 6 times 9, 6 times -7, 6 times -4. But then you have to keep the base, then you have to keep the base, and you have to add the exponents. And again, distributive property, what you're doing, 6 times 9, 6 times -7, 6 times -4. You're multiplying the coefficients. Multiplying the coefficients. Okay, multiplying the coefficients. Keep the base, add the exponents. Okay. Okay, now on 20, this is a multiplication problem. See the multiplication parentheses, see the parentheses and no symbol. So you want to be careful with something like 20, and very careful, pay attention to 20 and then something like 17, which are different. This is like adding and subtracting. See, you have parentheses, but see the big gap, and see you have either a subtraction or sometimes you'll have a plus sign. Whereas this, there's no symbol in between, no plus, no minus. They both have parentheses like this does, but this, there is, you know, gap, there's nothing there. See, there's here, there is. So you want to be careful with that. So this is a multiplication problem. This is a big multiplication problem. So you can either do the box method. Box method, you put one across the top, one on the bottom. Doesn't matter which one, but it's basically a term per cell. So I could do like 3x and -5, and then 2x plus 2. So I can do that if I wanted to. And then I could start multiplying. 2 times 3, that's 6. And on the x, you're adding 1 plus 1. So that gives you 6x squared, right? Okay. And if you wanted to show a little bit more, you could do 2 times 3. You could say like actually multiply 2 times 3 is 6x squared. Okay. Here you're doing 2 times 3, which is 6 with respect to x. 2 times 3, 6. And over here you're doing 2 times 5, which is -10. 2 times -5 is -10 with respect to x. And then down here you're doing 2 times -5, which is -10. And if you have like terms, you'll be able to see the like terms along the diagonal. Okay. And then you just on the side, you just add the 6x plus a -10x, which is -4x. So this is -4x. So you have 6x squared. You want descending order, 6x squared, and then minus 4x, and then minus 10. Constants go last. Constants go last. Okay, this is a trinomial. The degree is 2 because that's the biggest exponent, and then that's the leading coefficient because that's the biggest exponent. That's the leading coefficient, 6. Okay. Now, if you don't want to do the box method, then you can do the distributive property. And there's different ways to do the distributive property, but one way would be like you make the 3x your distributor, and then the second polynomial is times 2x plus 2. And then you go back and you make the minus 5 the distributor. You can do that. So this is the distributor. You could do that. Then you would start multiplying. 3x times 2 is 6x. 3x times 2, that's also 6x, right? 3 times 2. Okay, this is x squared, x times x. This is x times x. So this is 1 plus 1. So that's actually 6x squared. And then 6x. You have to be careful. Add, keep the base and add the exponents. So you have to be careful. Then over here you have negative 5x and then negative 10. Negative 5 times 2 is negative 10. And then you just combine. So this is first, just like we said, this is first. And then you have like terms here. So I have a mistake somewhere because this is supposed to match this. So there's a 6x squared and then there's the negative 10. But we're supposed to get the same answer doing it both ways. So we're gonna have 3x times 2 is 6x. So I just brought it down. I guess I didn't have to bring it down. This 3x times 2 is 6x. And I guess I can check because I have this, see, 6x. So I think the error is somewhere here. Because I'm supposed to have negative 10x somewhere. Oh, here it is, right here. It's right here. Negative 5 times 2x. Negative 5 times 2x is negative 10. Negative 5 times 2x is negative 10. Negative 5 times 2x is negative 10. Negative 5 times 2, yeah. So this was negative 5 times 2x, negative 10x. Negative 5 times 2 is negative 10. Yeah, so I couldn't see that for a while. Didn't see that for a while. It took me a while to find the mistake. And so, look there. And so now these are like terms. So you have the 6x plus the negative 10, right? That's 6x plus the negative 10x. That gives you negative 4x. That's what we have here. And then the negative 10 goes last, right? So that negative 10, which is last. So we get the same answer. This is using distributive. This is called distributive property. And then this is box method. This is called the box method. Used to be back in the day, used to be really popular in high school. And then there's also something called FOIL. First, outer, inner, last. So F means you multiply first terms. O means you multiply the outer terms. I means you multiply inner terms. L means you multiply the last terms. Okay. So the first term, this is the first term, and this is the first term of each one, first and first. So your first is 3x times 2x. So 3 times 2 is 6, and then you're adding these little imaginary ones, which is 6x squared. See, and see, you have that there. See, I also have that here. And then O means, usually teachers do this, they extend their hands out outside. Those are outer terms. Those are outside, outside, outer terms. So that's 3x times 2, which is 6x. So you see that's this right here. Okay, also that's that right there. And then inner terms, sometimes teachers do this inside terms. So that's -5 times 2x, which is -10. So you see that here. You see that here. So you have to be careful because you need to grab this symbol. Sometimes people only see the 5 and they miss a sign. And then last term, this is the last term in the first problem. This is the last term, second problem. So -5 is the last term in the first binomial. 2 is the last term in the second binomial. And -5 times 2. See, we see that here, and you also see that there. And then these, if you have like terms, you see them in the middle. And so 6x plus -10x, you see that gives you -4x. So we end up with the same result for all three of all three methods. So you choose the method you like and then just show your work. Okay, it's fine. Okay. So now the last problem, 21, you have this binomial, 7x to the first power minus 6. And then that's your binomial. And then across the top, you have your trinomial. It's your trinomial across the top. So this is if you're going to use the box method. If you like the box method. Okay. So here's 7 times -4, that's -28. And then the x's, you have to add the 1 plus the 2. So I give you -28x cubed. -6 times 4. So -6 times -4 is a negative, oh, positive, right? Positive 24x squared. 7x times 3x. 7 times 3 is 21. And then x1 plus 1 is x squared. -6 times 3 is -18x. 7 times 2 with respect to x, 7x times 2 is 14x. -6 times 2 is -12. And then if you have like terms, you usually see them along the diagonal with this box method. So you can see you have 24 and 21. That's 20, 30, 40, 44, 45, I believe, 45x squared. And then -18 plus 14, and you can use your calculator for that, but that's -4x. So then it looks like you have -28x cubed plus 45x squared minus 4x minus 12. Okay. Or you can do the distributive property. If you do the distributive property, you make one of these a distributor. So you can make the 7x the distributor and then times all of that, 4x squared plus 3x 2. And then take the -6 times -4x squared plus 3x plus 2. You can do that. Distributed property, that's called distributed property. Okay. So then you're multiplying using distributed property. So 7 times -4 is 28, right? 7 times -4, -28. And then on the x's, you have 1 plus 2. So it's -28x cubed. So see, that matches with this. And then 7x times 3x is 21. And then on the x's, you're adding this one, this one. So that's 21x squared. And then 7x times 2, that's 14x. And then -6 times -4x, that's a positive 24x squared. -6 times 3x, it's a -18x. -6 times 2. So that you should see 24x squared, you should see that here. -18x, you can see that there. And then -12. So that does show up then in both locations. And then, but then you need to combine your like terms. So you only, okay, this one, you have that spine solo there. But then see these here? Those you can combine that. 21x squared and 24x squared. 4 and 1 is 5, 2 and 2 is 4x squared. So you see 45x squared. And then the 14x and the -18x. So 14x plus -18x is a -4x. Okay. And then on 22, we're finding the product. I didn't put my I'll get that later. I'm on the last 2 problems. I didn't get my put my I'm almost done. I'm on the last 2. So I'll receive. I'll go back and answer the phone call. Yes, I'm almost done. I want to finish this. So 22 and 23. These are the find the product of the binomials using the appropriate special product difference of 2 squares, or square binomial sum, or square binomial difference. Okay, and that's what's happening on both 22 and 23. So for those, I need to come back down here to this page, special products in your workbook, and I need to grab those formulas. So I have to match them with the formula. So let me see. I have, these are called conjugates. They're almost identical, like the 5x and the 3, the terms of the binomial, except one, this is a -3, this is a +3, minus and plus. So when they're very similar like that, except they have a negative, I guess you could say opposite, they're very similar, they're almost identical, except they have like opposite second terms, right? These are almost identical, except they have opposite second terms, 3 and -3, opposite second terms. Then that's what makes them conjugates, if you're wondering, like conjugate. And then that would be this formula. See, these are almost the same, except these are conjugates. Okay, so then this equals, the formula is x squared minus a squared. That's the formula. So it looks like this, and so this is the formula. So it's at x plus a, x minus a, and it looks like this. Okay, so then we have the first term, and let me see how I have that in my template. That's what I have on my template. So I have first term, second term. I'll do that. So first term is 5x. Second term is 3. So I know you have one negative, one positive, but the sign is already taken care of. So we kind of just look at their absolute values. And I don't worry about being a positive or negative because the sign's already here. So then the first term is squared. So then you take 5x and then you square it. And then you have a minus. And then the 3 is squared. So that's the idea of using this formula. You're substituting, you're subbing. So you're letting, you're gonna let x equal, and you're gonna let a equals kind of what's happening. You're gonna let this be x, and you're gonna let this be a, and then you're gonna substitute them into your formula. It's kind of what's happening. So then 5x squared means 5x times 5x, and that's 25. And then you have to add your exponents. So that's 25x squared. And then the minus is part of your formula. And then it's 3 times 3, which is 9. Okay. Okay. So they're saying that this is supposed to be a shortcut. If you were to do FOIL or the box method or distributed property, you would get the same answer as this, but they're saying this is a shortcut. And the reason why you want to be exposed to this is because next semester you have to take college algebra. You have to learn a whole chapter on factoring. And so you need to be aware of this, because in factoring, they give you a problem like this, and then they say factor it, which means you need to go back and make it look like this. So that's why they want us to expose you to this section, so you have a little bit of a heads up on factoring for college algebra. Okay, and then this problem down here, this one mimics this one. These are almost identical, except that the signs, see, this one they're all positive, this one has one negative because of this. So this is almost identical. And so, but this is 3x plus 8 quantity squared. So that falls under this. So if I copy down that formula, and then like I have here on your sheet, see I have the formula there, and see I have first term and second term. So the first term is 3x and the second term is 8. Okay. And so it's like you're letting x and then you're letting this be a. It's like your x and your a. Okay. And then you're gonna substitution. So then here you have x squared. So x is 3x quantity squared plus 2 times a, and a is 8 plus a squared, and a squared is 8. Okay, so you're substituting using this, okay? And then when you do your math on that, 3x times 3x, 3 times 3 is 9, then you add the exponents. So that's 9x squared. Okay. And then 2 times 8 is 16, sure, plus 16. And then this is 8 times 8, which is 64. And And let's see. I'm just gonna double check. Looks like I have a mistake now. This number 22 was correct. This one I'm showing here 48x. So I made a mistake. Where is the mistake at? It's it's 2 times a times x. 2 times a times x. So there's a 2 times the a is 8 times the x, and x is 3x. This is what's missing. So the 8 times 2 is 16, but then times 3x. So this has 3 products, and I was missing the x, which is x is the 3x. And that will give me 48. 16 times 3, that will give me 48x. That goes here. So you have to be careful with that little mistake. Of course, you get partial credit. If you had that on the test, you get most of it is right because you got the last 2 terms. It's just the middle one. But again, you have to show your work using this formula. You got to show your work using this formula. Okay. This problem can be done like, if you do 3x plus 8 times 3x plus 8, this can be use the box method or FOIL or distributed property. But for these, though, they're saying it's faster to do a special product. And so they don't want you to use that here. On the other problems, like 21, like on 21 and then 20, you could do that. 21 and 20, you could do that. 20. But not on these. These you have to use the special product. You have to be familiar with the formulas. And again, it's because when you take college algebra, you're going to do factoring. They're going to give you something like this. Then they want you to factor it, which means they want you to go back and make it back into this. So that's why they want you to be exposed to this, because that's going to help you with college algebra if you have to take it. Okay. All right. Okay. So I hope that helps you with your studying. And just if I went a little bit too fast on some of these, so hopefully you can go back and rewind it and look at it again. Sorry about that. Okay. But I did do some kind of a review for you. So I hope that helps. Good luck on that. Okay. Mine on math. Take care. Good luck with your studying. Study smart. Bye-bye.